Welcome to organic ISP number 3. Right? We're gonna add a little bit to the next one. We started with single straight chain alkanes in the first nomenclature video. Now we're going to add a little bit more complexity to it. We're gonna add branches. So since carbon can form up to 4 bonds, right? If we take a single straight chain, right, we can assume that this carbon has 3 hydrogens on it, this one has 2, and then this one has 3, right? So that each carbon has 4 bonds. But those bonds don't always have to be filled up to hydrogen, right? Carbon can make more bonds to itself, which allows it to branch, right? So we need to find a way to name branched alkanes. So we're going to start off with just single branches, right? So what we can do is we can start off with a main chain, right? So we still name the main chain the way we name a straight chain alkane. So since this has 1, 2, 3 carbons in it, right, we're going to call this propane. And if I add a branch to it, right, just for clarity, I'm going to put the branches in a different color, right? Here's a red branch, right? So I'm adding an additional carbon, right, to the middle of this chain. So now it has the main chain in black and it has a branching chain in red. And there's just going to be 1 carbon there on the branching chain. So we need a way to name the branch. And what we do is we use the same prefix for the number of carbons, right? So if there's 1 carbon in the branch, we're going to use the prefix meth, right? And rather than putting in the suffix ane, right, for branches, we're going to use the suffix il, Y-L, right? So this 1 carbon branch is going to be called a methyl branch, right? Then to name the entire compound, right, all we have to do is put the name of the branch in front of the main chain. So this molecule would be called methylpropane. Right? That's it. It's just methylpropane. Right? It's got a 1 carbon branch, methyl, on a 3 carbon main chain. Right? Now there's things you have to watch out for, right? I'm going to use a propane backbone again. 1, 2, 3, right? And if I were to put a additional methyl branch, right, at a different location on this, right, say here, right? Even though I've added 1 carbon to this, I wouldn't call this methylpropane because the addition of additional carbon here, right, actually doesn't create a new branch. All it does is elongate the existing chain. So we wouldn't call this a 1 carbon branch on a 3 carbon main chain. We'd actually just call this carbon 4, right? In which case, all we'd have to do is name this butane because it's a 4 carbon long chain, right? So don't be fooled by branches that appear at the end of a chain, right? All they really do is make the chain longer, right? Now, for simple, very short chains like propane, right? There's only 1 place we can put a branch without elongating the existing chain. It can only go in the middle carbon, right? So there's only 1 kind of methylpropane, right? We can't put a methyl branch anywhere else on a propane molecule. So we can just call it methylpropane with no issues, right? So down below here, I have put in 3 pentane chains, right? So that's 1, 2, 3, 4, 5, right? And if I add a methyl group to pentane, so I have a pentane main chain, okay? I can add a methyl group here. So that'd be 1 carbon branch, right? So that's going to be a methyl branch. Okay. And so I would put methyl in the front. Okay. And there we go, right? We have methylpentane, right? Now, to show you that this name can't be left as it is, right? I've drawn in pentane again, right? And to illustrate my point I'm going to make here, okay, I'm going to put a methyl branch on this carbon, okay? So, although we have a pentane main chain in both cases, and we have a one carbon methyl branch in both cases, right? These molecules are actually different, right? This methyl branch occurs right in the middle of the pentane chain, right? And this methyl branch occurs on the second carbon of the pentane chain, right? So the branch isn't in the same place on both molecules. So we can't call them both the same name if they're not the same molecule. So we need a way to differentiate between, this is methylpentane as well, right? Right? What's the difference between this methylpentane and that methylpentane? Well, the difference is the location of the methyl branch, right? And this is where the numbers that I've been putting in actually become important, right? We can actually distinguish between this methylpentane and this methylpentane by saying where the methyl group is. And we just do that by saying, well, which carbon on the chain is it attached to? This methyl branch is attached to carbon 3 on pentane, and this methyl branch is attached to carbon 2 on pentane. So all I do is I put in 3 hyphen and say that this is 3-methylpentane, and I put in 2 hyphen, and this is 2-methylpentane, right? So I've drawn in a third pentane to illustrate an additional point. What if I put my methyl group on the 4th carbon, right? This would also be methylpentane. And you might think to call this 4-methylpentane, right? But if I took this molecule and I just rotated it in space and flipped it around, right? Then it would look exactly the same as 2-methylpentane, right? So this molecule and this molecule aren't actually different. They're the same molecule. The methyl branch occurs from on the second carbon from the end of the chain, right? It's just that one molecule is flipped over in space compared to the other molecule, right? But they're really just the same molecule. Now, we don't want to give 2 different names to the same molecule. So if I call this 4-methylpentane, right, I'm actually giving these 2 molecules, which are the same molecule, 2 different names, 2-methylpentane and 4-methylpentane. So to avoid this, if you have 2 identical molecules, right, you have to give them the same name. We always give them the name that includes the lower branch number, right? So we would never call this 4-methylpentane because 4-methylpentane is the same as 2-methylpentane. So to see whether or not you're naming it correctly, there's a trick you can always do. If you've named it, you can always renumber the branch in the opposite direction. So if you renumber the main chain in the opposite direction. So if I number this 1, 2, 3, 4, 5 in the opposite direction, and that changes the name to 2-methylpentane, right? Since 2 is lower than 4, right, 2-methylpentane is correct. 4-methylpentane would be incorrect, right? And as I mentioned before, if I were to draw in 2, 4, 5, right? 1, 2, 3, 4, 5. If I add a methyl branch to either the 1 carbon or to the 5 carbon, I'm actually just making the main chain longer, right? So this would turn it into a hexane, right? Instead of a methylpentane, right? So adding things to the end of the chain only makes the chain longer. Okay? So we've distinguished what do we do if we have the same main chain and the same branch length, right, but on different locations? Well, then we just put a location number in, right? What if the location number is actually the same? If we just flip the molecule around or number it in the opposite direction, well, then we always choose the lower location number, right? Depending on whether you number it one way or number it the other. So we could try one more example. And probably show one more point. If I do 1, 2, 3, 4, 5, so I'm going to start 1, 2, 3, 4, 5. Okay? And I'm going to put in, instead of a 1 carbon branch, I'm going to put in a 2 carbon branch this time. Right? And I'm going to call, so you could call that F il. Right? So the 2 carbon prefix is F, branch suffix is il. Right? And then because this has 5 carbons, we call this pentane. Right? And because you could potentially put that branch on a different location, right? We would like to call this 2-ethyl pentane. Right? So this is the way you normally would do this kind of molecule, except for the fact that this name is incorrect. Right? The reason this name is incorrect is because you have to be careful when you're determining what's the main chain and what's the branching chain. Right? When you're finding the main chain, right, you always have to look for the longest chain that you can find, and that will be your main chain. Right? By taking that pentane, which is 5 carbons long, and adding a 2 carbon branch to it, right, I actually create a longer chain than 5. Right? If I were to remove these numbers, right, and start numbering here, 1, 2, 3. Right, I can continue along the branch, and this is why it's important that you don't necessarily have to look at branches in straight lines. Right, I'm going to follow this branch along this way, 5, 6. Right, there's actually a 6 carbon long chain here. Right, so the rule is always look for the longest chain to become your main chain. So that means that in this case, pentane is not my main chain. Hexane will be my main chain. Right. So let's make this black. Right. If that's my main chain, then in actuality this is my branch. And it's only 1 carbon long, not 2. Right? So this would not be a 2-ethyl pentane. This would in fact be a 3-methyl hexane. Okay? So to put this in steps, right? 1, find the longest chain. Right? You may have to exhaust different options. So if you go here, you can go 1, 2, 3, 4, 5. Okay, that's fine. Try this direction, 1, 2, 3, 4. Okay, right. Start from a different end, maybe 1, 2, 3, 4, 5. That's 6, 5. 1, 2, 3, 4, 5, 6. Ah, we've now gotten to the longest chain, 6. Right. So you may have to check some different paths in order to find the longest chain first. Find the longest chain. Right. Name it as the main chain. Identify branches and locations. We can use that. Formulate name. Alright, so we're looking at this, find the main chain first. Okay, it's 6 carbons long. 6 carbon long chain is a hexane. Identify any branches and their locations. Well, there's 1 single carbon branch, so that's a methyl branch on the 3rd carbon. So we call it a 3-methyl hexane. Okay, I think that covers everything about single branch alkanes.